All right. Let's go ahead and make sure you all have the class. Copy the link, share it into class. And there we go. All right. Let's go ahead and see who's all here. All right. Looks good. All right. So, I wanted to go ahead and talk about the assignments, or one big assignment that'll count towards 2 assignment grades for you all. And that is, we're going to start talking about, or let me rephrase that. We're going to start actually making use of all the parts and pieces that we've learned so far. And so far, we've been talking about how are classes designed? What is an interface? Why do you make something an interface versus making it a parent class? Things like that. And we really haven't, I showed you one example of MVVM, model, view, view model, and how that sort of would work. And that's a more advanced pattern, but I want to start and bring it back and walk you through the steps of understanding why you would start designing classes the way that you would when you're working on a bigger project or an assignment or something for work or whatever the case may be. So, in doing so, I wanted you to look over 3 Wikipedia articles: multi-tier architecture, model view controller, and model view presenter. I also have model view model up here, and if we have time, we'll briefly talk about that. But the ones in particular I want to talk about are the multi-tier architecture for today. And then how those actually work, how they're implemented, things like that. So, who here has read these, or at least skimmed over these articles in the video that I linked to you? That is proverbial crickets chirping. Okay. So, the easiest design is this here: presentation, logic, and data. And it's almost so simple that it's not difficult to wrap your head around just from thinking about it for a little bit. But it's foundational, and let's work our way through why it's important. So we have a presentation tier, we have a logic, and we have a data. And we've been talking about how we want to separate out concerns. So we want to make a modification to one class impact as few other classes as possible. That's called coupling. So we want to decrease the amount of coupling between classes to make them highly decoupled. Now, that's a goal. It's not even realistically obtainable, but that's a cost-benefit analysis you'll start learning as you start developing bigger and larger projects and working on them. And the biggest issue is not when you're first writing the code. It really doesn't matter. You could write spaghetti code as long as it works. The issue is actually later when you're going to go back and edit your code. The better you design your code up front, the easier editing that code will be. Now, a perfect example of that is something I'm sure you've all ran into. I did as a early developer myself. Somebody shows you how to do something. They talk about it. They give you a demo. They might even give you some sample code, but it's not documented and you don't quite understand it. Then even an hour or two or a couple days later, you go back and you try to look at that code and you don't remember exactly what it's doing or why it's doing what it's doing. Now, that's an argument for better documentation, most likely better method and function or method names, and a lot of things like that. But everybody's going to run into situations like that, and so that's why we name things and we design things so that everybody can know what we're talking about. So everybody's familiar with the term meme, obviously, nowadays, I would assume, correct? The current working definition that most people know of. So I'm not even going to wait for, I was going to wait for replies, but no. So the original meaning of the term, I believe, was coined by Richard Dawkins to talk about terms of art that are only known within a sub-community of individuals. So a good example of this would be people who work in the trades, like carpenters, electricians, etc. They're going to know what a header is. When you tell them what a header is, they're going to have one understanding of what that means. That's going to be the piece of wood over a door or window, etc. Now, you say that to developers, and you say there's a header, and developers are going to think of, depending on what programming languages they know, they're going to think of headers in like C files or C++. Now, does that make sense? The idea of different subgroups having different vernacular and vocabulary for things. Okay. The reason, this is sort of simplistic and basic, but I want to circle back and forth a couple of times to make sure this makes sense for you all. And developers and software designers have learned that if we all know a common set of language or terms as developers and project managers, etc., if we know these terms, that's fine. Eric, that's fine. Hope everything's fine. If we know these terms up front, what it does is it creates a better dynamic of communication among multiple entities, whether they be developers, managers, CEOs, not quite, and I'll get to that here in a moment. Now, if I was talking to you all about the interface, okay, you all are going to understand what I'm talking about. But if I go and I talk to a business leader, they're not going to know what a Java interface is. But that's fine. They don't need to. And so you kind of need to know what audience you're targeting with what vocabulary. And this is sort of a basic, like, how to survive in the world type concept. And the software developers have learned that they can design and create meaningful names of things. Yeah, that is true. We love jargon. But jargon is useful because you haven't probably worked on many large projects as developers yet, or possibly even any even pair programming projects. Jargon becomes super important when you have lots of people all working on the same project. If everybody knows that we're going to, let's go for example, we're going to create an interface that talks between, and here's a good example, the presentation layer and the application layer. We're going to create an interface between these. Okay, everybody knows what we're talking about, or will at that point. And if we say we're going to make an interface for the business layer that the application layer will call, everybody knows what we're talking about. If we say, and in this class, you'll already know some of these jargons because that's what I've been hitting at with building your knowledge of Java and object-oriented programming based off of software design patterns. Because here's our database layer. Our database, we want to be a singleton. We only want a single source of truth for all of our data. Okay. Well, that singleton, maybe it has the business layer, maybe that contains some factory of different components that we can access in the logic. So one component might be, let's just make this simple. Maybe it's a store. So the business logic may be, one part of it might be ringing up a customer. Another part might be actually tallying the result, calculating the tax. Another part might be inventory. Another part might be ordering, etc. So you have these different parts, and maybe you have a builder, or maybe you have a factory. Like, these are really simple examples, but now that you know what these terms mean, you can sort of start picturing in your mind, oh, here's a piece of code, here's a piece of code, they're going to have these connections between them, there's going to be a builder over here. You can start building a mental map, and as developers, being able to do that, you can then talk to more experienced developers and better explain what your code is meant to do and what you're trying to have it do, and they'll be able to assist you. Same thing with managers. They're like, okay, well, you want to build 15 classes. All right. So each one of those classes roughly are on average going to take 2 hours. So we'll give you 30 hours and a 10% margin of error, or 20% margin error. So there's 36 hours. You should be able to get that done this week, working 40 hours, etc. You start doing these estimations of how long code are going to take, and you start being able to design these things. So that's sort of this like big brain concept of why learning these things are important. And the most simple one is the 3 layers. And just think of it like you're building a cake. You have bottom layer of the cake, then you have some icing, you have another layer of cake with then you have icing, top layer, and then top icing, I guess. And those icing layers are going to be how you define the interactions between the different layers. Does that make sense to everybody? So we're just going to try and go over concepts at this point. Now, the layer design, often, not always, but almost always, the bottom layers are contained in the upper layers. So you would have a database object, and that would be stored in the business object, the logic layer. And then you would have a logic layer. We'll just simplify this down to 3. You'll have the data, business, and presentation. So you have the business object with the logic in it, and you have that inside the presentation layer. So that's really simple and straightforward to learn. It's not always the best when it comes to complicated designs. So if you're doing a calculator, okay, maybe that's pretty straightforward. You only have a single window. We'll just call it a window, whether it be a mobile app or a web app or a desktop app. We're just going to call them windows, whether they be actual windows or they be activities in Android or I believe iOS calls them controllers, whatever the case may be. You're going to have one thing, basically. And yeah, maybe a couple buttons and an output. Simple calculator like that. That layered approach might work. And it's good to get practice doing this because all the other approaches build off of this concept of having some form of rules and processes by which, one, you have the logic separated out. So data, business, presentation, they're all in different places. That's a really good start. I mean, if you get to that point, you have code that is starting to become professional. So that's a good thing. And the more you learn and more you write code with this practice, you'll start realizing some of the limitations. So how do you separate out the presentation layer? Okay. What if you have multiple windows? Does each window contain its own logic, or do you have one global logic? So you have these concepts going back and forth. Generally, you would have a separate logic. I'll just give the answer for that one for each window. And then you'll have, we'll just talk about Android for a second. You'll have multiple activities, which are what you see, and you'll have, depending on different libraries you use, you might have literal like lines on a graph going between click this button and it'll open this window. You click this button and it'll take you back to that window, that type of thing. Or you might have them programmatically declared, etc. It's not, the details aren't important, just the idea of going back and forth between windows. You have some logic that might be in the view, it gets a little blurry. And so why I brought that up was when you start getting more complicated examples, you're going to see that the separation of these layers starts blending sometimes. And the more you can prevent that, the better. But you have to do it within the limitations of the platform you're on. So, what do I mean by that? Does anybody have an idea? Probably not, but that's fine. Give everybody a couple seconds to see if anybody has something. No? Okay. So, a good example would be Android. An activity is sort of both the view, what you're viewing, and your logic. At least part of it. And so, unfortunately, you're going to blend, no matter what, some of the presentation logic into the layer of the view, the presentation. Whereas then you'll have business logic separate. And so there's always this little bit of, we have to kind of blur the edges somewhat to make it work in the platform, framework, operating system that we're working in. So how much does that happen? That depends on your experience level and what you're programming. So in Android, quite often that happens. We talked about a click listener before and how you click a button and to make it actually do something, you set a click listener. Well, setting that click listener is sort of technically logic, at least in my mind, that when you do something, you're setting logic to trigger something else to happen. So you would set that in your presentation, the window you're viewing. But then when that button is clicked, you notify the logic. So you sort of have this intermediary between the layers. Does that make sense to everybody? There's always sort of exceptions. Okay. Let's Actually, this is a better picture. So you would have your presentation tier, so your view, your logic, and your data. You would have a data object inside, you'd have a data object inside your logic object, and your logic object you would have inside your presentation or your review. That's the canonical first project that everybody learns the first time when they're working together in a group is making these. And then you define the interface, aka the methods, of how the data tier will communicate with the logic tier and how the logic tier will communicate with the presentation tier. Does that make sense to everybody? And can you, in your mind, start thinking and picturing blocks of, let's just call them blocks. They don't have to be real code or anything, but just picturing how those would connect, how they would exist. If you can, that's the basics of a lot of the UML diagramming that we briefly hinted at in the beginning of the semester. If you take software engineering, you'll cover UML diagrams much more. So, this is pretty straightforward. Does anybody have any questions about this? We're just going to briefly talk about these today, and you should be able to start comparing, contrasting them for your first or your upcoming assignments. So the question is, and it's a good question, when two layers blend, can you just make the blended part its own layer sometimes? That is a really ambiguous question because yes and no. It really depends on, so for example, Android. Android has some complexities in this because you can define the click listener inside XML. So you can the default way of defining your UI is an XML file that's separate from your Java file. Now there's a lot of like asterisks. There's like 1,000 asterisks in that statement. But now it uses Kotlin. You can use Compose. You can program your UI in Compose. There's a bunch of different things. But let's just pretend you're using XML and you're using Java. In the XML, you can put an on-click and then point to somewhere in your view where the logic goes. Or you can use data binding, which is sort of we talk about in the model view model. And you can bind the view model to the view through a data binding mechanism. That's much more advanced. But the idea of just programmatically in the XML clicking or setting the click listener to some method in the view or method in the activity or whatever the case may be makes sense in that logic. But here's the question. You had an XML file, and now its original purpose to be the layout of your different views, whether they be push buttons or text views or edit text where you can enter text into them. what is that breaking it when you put the logic in the XML? But if it is breaking it, is it still fine because it's a lot less, it saves you a lot of boilerplate code? That's sort of the like perennial question Android developers are always asking themselves. New methods to do different things. Cost benefit. Now, the benefit to that is it's a lot less code. It's literally one line of code in the XML. The drawback to that is you have to have a method, public, void, and it accepts a view. If you edit that method and you don't have it have that signature, then the XML will break, and not always will it instantaneously tell you that it'll break, depending on how your project is set up. It should, but lots of shoulds don't actually end up happening. So then at runtime, or if you're really unlucky, or at compile time, if you're lucky, you'll get an error. And then you'll have to change things. So doing it that way has costs. There's increased, literally compiling a big project can sometimes be one of the most tedious portions of it, especially when you're trying to figure out how a UI element works that you can't just write a unit test for easily. The other option would be learning data binding or setting up the click listener in code. Setting up the click listener in code is much more straightforward. You as a new developer, if I showed you a bunch of code with click listeners written in Java, I would bet even you all would be able to understand, set click listener, new click listener, and then logic. Okay, you would understand that. Now, if I set data binding, and I bound that to a view model, and there's a billion different variations, probably. The more complicated I make it, it makes it more complicated, one, to even explain it, even if you know what you're talking about. But two, and this is a huge one, this is one that a lot of people overlook. How easy is it to onboard somebody onto that new technique? I personally still don't use Compose because we have, where I work, so much layouts that it's just not worth it to us for right now to start using Compose. Now, are some people who are huge proponents of Compose saying that's naive? Maybe. But there's benefits to us not changing our work process. We don't have to learn anything new immediately, and we can continue to make productive code. And that's a cost-benefit analysis. And this is just something you're going to learn as you become a more experienced developer, manager, mentor, etc. You're always balancing these different things. Now, often, if you are seeing, and here's a good idea, if you're seeing code written over and over, there's a problem. It means that you can probably figure out how to refactor your code to make your code more succinct. Even if it's one line, if it's a long line of code, and you're calling it over and over, maybe put that one line of code inside a method and just call that method. Now, you can make the method name short, and then every time you change, that has a couple benefits. If you need to have that code be exactly the same everywhere, one, you're improving your code readability because you're making a bunch of long code, moving it into a single method. And then if you change that single method, the changes propagate out through your file. Now, that's useful. Now, what if it's you're just calling it twice? Maybe it's not worth the time. Maybe it's just better just to have the 2 lines repeated. Maybe not. I mean, there's always benefits and drawbacks. Now, if you think that those 2 lines might, or you highly suspect they're going to change quickly, maybe you purposely leave them the same for right now, expecting them to change relatively quickly. So these are just experience. These are essentially just things that you learn as you develop more and you work on projects long enough. Does that all make sense? Sort of a little rambly, but these are like how would I phrase this? Nuggets of wisdom from experienced development. And you can always improve your code, basically. But saying that, you also want to make sure not to spend too much time trying to improve your code, and in the process of improving your code, hurting the code readability. You could start using really multi-layered generics and start making it seem a lot less usable from a developer standpoint versus just having objects. Like, there's a bunch of, I've ran into lots of weird examples like that. So, Aaron says that in coding, it's a bit about the cost benefit of how it works, but also looking at the cost benefit of how it will be read and interpreted. That's at least what I think. And that's correct. Good example of that is algorithms, sorting algorithms, etc. If you're sorting 10 items, just use a bubble sort. Like, whichever one you can write in the smallest amount of code, the quickest, it doesn't matter. Now, if you're sorting 100,000 items, don't do that. Actually take the time to use a proper sorting algorithm. And realistically, you just call .sort. But you get my point. If you are, because at that point, what's the most expensive thing? You might not have heard this phrase. The most expensive thing in software development is software development. It's the cost of the developer's time nowadays. It used to be hardware, etc., but now it's without a doubt developer time. So if the developer, and it doesn't impact runtime significantly, just write the simple answer and then get it done. Because you can, if it starts scaling, you can always go back and improve the code later and implement a better sorting algorithm. Does that make sense? And software design like this is sort of the inverse. You want to spend a little bit more time, especially as early developers. You want to spend some more time planning out your code so that you're following one of these patterns. And essentially, you're just going to be told by somebody more experienced which pattern to use. And whether that be a faculty member or a instructor or a boss, etc., or somebody you know who's more experienced, you're going to follow some pattern, and you're going to learn from doing so, basically. Now, we talked about here data, logic, and presentation tiers. And we talked about generally you have the database inside the logic and the logic inside the presentation. Like when I say inside, I mean the actual object exists in the tier above it. Does that make sense? And the data tier has inputs and outputs. This is what we haven't talked about yet. Is tiers are going to have inputs and outputs. And that's what this defines how things interact. So here's model, view, controller. So view is the presentation layer, but you'll notice model updates the view. The user interacts with the controller, and the controller manipulates the model. And so you have a cycle here. And this makes sense conceptually. But think about uses the controller. If you're on a mobile phone, let's say you're on the YouTube app. What are you interacting with? Well, you're interacting with the presentation layer. So you see the uses is pointing back to the view. So how do you handle that? And this is one of those issues where I said you always have to adapt your concept of the model or the software design concept, or I guess just pattern. I was thinking of another word, but architectural pattern type thing here. And this software pattern of model, view, controller, it breaks down because you can't have the uses go to the controller. The uses have to go back to the view, and then the view goes to the controller. So the user's over here only interacting with the view, and this uses points here, and then you have a new arrow from here to controller. Does that make sense? You always have to adapt these patterns to the system you're working on for it to really make sense. And here's another one. There we go. And here is the model, view, presenter. Now, this might make more sense, because look, let's pretend we're a mobile application again. Here's our view. We pass user events down the presenter. We update the model. The model changes, updates the presenter updates the view. So we have a cycle again, but this time it actually understands that there's user events and view updates are going to be from the view to the presenter. So this is a pattern that was really popular with mobile development for a long time. Actually, I don't know if it's really gone out of favor, but there's drawbacks to this. How many lines in and how many lines out from this view here, if you could get it to actually work this way? How many lines into view do you have, and how many lines out? Only one in and one out. How many in and out from model? In and out from controller. Theoretically, this works great, but you come back here and you see there's 2 in and 2 out to view, because the user has to hit the view. Come back to here. Well, we're back down to 1 in and 1 out. And does that make sense why you want to lower the amount of interfaces connecting different things? There's lots I'm skipping here, and I understand. But I do want you to read over these and minimize this. And particularly start thinking about the different components and their motivation, and or history. It's the good thing and bad thing about Wikipedia. Lots of information, not always the same on all the different pages. Web development, etc. So, I really just wanted to kind of point out the things that you should be considering. Is how are these layers, how are these parts of the pattern, are they connected? Where do they actually exist? How do you modify these to work on different platforms? That might be a little more difficult for you, but if they talk about it in here, like, oh, web development, maybe some of these patterns are more useful in different environments, etc. Oh, and that's that MVVM testing we've talked about previously. Maybe these patterns have costs and benefits and different approaches to how they're implemented that might make them better in some scenarios. So start thinking about that. And you're more than welcome to do more Googling, read up other people's opinions on this. But my key recommendation is, if you do start, and I would recommend doing it, looking up other people's opinions, look up a handful of them and make sure that you agree with what they're talking about. Because often you're going to find subtle nuanced differences between what different people say the rationale for different patterns is. Is that it? Does anybody have any questions? No, we kind of just skimmed over these. Like I said, I did want you to have these read. But the main thing to think about is, how are these connected logically? What is the flow control? Are you having, how many layers are there? How does that work? So I'll talk about model view presenter. The presenter here, if you'll notice, everything goes through the presenter. So the number of methods in a presenter can get quite large. That could be a downside, especially for a complex view that you're interacting with. So think about I don't know, Google News or something like that, where you're scrolling through lots of data, or a Facebook app. Single presenter with all the different data and all the different views you could click on would have a lot of logic in here. So basically, I just want to give you enough information where you can start thinking about these things on your own. If there's no other questions, that's it for today. I will go ahead and post the written version of the assignment before this weekend, and it will be due after break. So we'll have one more class on Tuesday. Is that correct? Yes. We'll have one more class on Tuesday before to go over that assignment if anybody has any questions.
Otherwise, I'm done for the day, and we can go ahead and head out, and we can be done. Does anybody have any last questions before we head out? Doesn't look like there is, so we will go ahead and stop here, and you all have a good evening, and have a good weekend, and we'll go from there. Bye.